us on about the course he has practiced for good years, and he will be our very first speaker today. That's Engineer Matthew Stanley Kinyanjui. So, colleagues, ladies and gentlemen, join me as we welcome our very first speaker, Engineer Matthew Kinyanjui. Thank you.
Thank you so much, Remigio. I hope I'm being heard well. Maybe just to attach a face to the voice. So that's what I look like. I'm Matthew Stanley Kinyanjui, as you had mentioned, and I'm going to speak about integrity, but integrity coming from the aspect of process facilities. So when I was approached, I was given several things to talk about, and I have tailored all my presentation to be within safety and risk management. And then within that particular one, I'm talking about major risk management and integrity. So I'm going to also be able to share my presentation. So I'll speak to it as we follow. The other thing, I would love also to recognize the presence of someone called Ferdinand Musasizi. I sat with him in the same class, and he has worked as well. So he'll probably have 2 or 3 minutes to say something to us and to encourage us to move on. So allow me to share my screen. Just a minute. So I hope my just a minute. I need to put this in presentation mode. Okay. So is my screen seen? Is it visible? I just need a response to that, then I can be able to move on.
Matthew, I can't see it. Okay. If somebody is seeing it, fine, can proceed.
Okay, so my presentation, as I said, it's about major risk management in chemical process industries. And why this specific one is because, one, when we talk about safety, we think that it's only about safety of people. But there's a very clear-cut difference between health and occupational safety and process safety. And again, within the process safety aspect, all these get into the whole broader topic of integrity, managing integrity, because as process engineers, as chemical engineers, what we need to do is to design facilities that are safe for everyone, to protect the environment, but then most importantly, to protect ourselves. Now, in there, I've structured the presentation to have an introduction, just to introduce us to process safety, and there's a few terms like hazard, risk, and then process safety management. Then I have process hazard identification as the second part of the presentation. And then finally, I'll talk about risk management. So if we're to start with process safety, it's basically a framework to manage the integrity of operating systems that usually handle hazardous substances. So whenever we are designing any facility, there are two things that we need to ensure. One, which is first, is the safety of the people, but then two is the profitability. So the profitability is all that you people do in energy balances, things to do with heat and mass balances, optimization. That's there. And now, wherever there is a process industry, there is a hazard. There is a process or a chemical that has capability of causing harm to either you, the operator, or the environment. Now, we usually interchange the word risk and hazard, but these two are very different. So the risk is the likelihood of actually an incident occurring. In other words, if we to look at risk in a mathematical way, we look at it as the probability of an event happening and the extent of harm of that event, which we are calling the severity. And managing all risk and hazard involved in process facilities is now what we call process safety management. How these things might look to be far-fetched, but if we're to get back to just a few examples of things that have happened, they've been very devastating and they've caused extreme negative effects. If we're to look at, I'll only talk about this Machondo blowout and explosion. It was a deep, an offshore deep well, and something happened which led to leakage of hydrocarbons. And because of that, unfortunately, 11 people passed on and then 17 were injured. But the company, BP, had to spend so much money to do an environmental cleanup. So you realize that in the event of an accident at a process facility, the consequences are so big. They will, we might look at them first with worker, like people dying, but sometimes if it's in a very environmentally protected place, then you have so many things that you need to do. If it's on a lake or on a river, you'll have to do cleanup. Aquatic animals might die. Terrestrial plants might also dry out because of the nature of the material that you're handling. But then apart from that, when an incident happens, there'll have to be investigation. So when they're investigating, specific countries or specific places do have put a halt onto the operations of the facility. So that means that you lose productivity. That is one. Two, if you have any insurance, if you have any insurances running, then because of that incident, then your insurance premium is going to be high. Then the worst of it all is reputation. When I was in Egypt some time back, there was an accident that happened with a company I was working with, and because of that bad reputation, they actually contemplated on stopping operations of that company happening in, operations of that company continuing in Egypt. So now we have spoken about how adverse the accidents can be, and now we need to understand how do we identify hazards, how do we manage, because if we can't manage a hazard or we cannot manage risk without understanding the hazard, one, without also understanding the magnitude of that hazard in the event that an accident occurred. But before we go into that, we will also try to look at the different aspects or the different types of hazards, which one, there are residual ones, and you cannot entirely eliminate a hazard, but you can control it. And so if you have residual risk, is more like you're just having a tolerable a hazard within a tolerable range during the operation. But then sometimes your operations downgrade, and because they are downgrading, you get used to it. For example, you might have a leaking valve in a facility on probably a steam line. Now, it's so easy because that steam line is out of sight of people. So it's really easy to think that no, let's leave it, let it leak for a short while. But now you're normalizing risk, and that's what we call a normalized risk. And then the other one, operating risk, is basically you have a process. Before you start it, there is nothing. There's no chemicals in it. But when you start operating it, you introduce chemicals. So that's operating risk. There are different tools that we use to identify hazard. And these tools range from extremely simple ones to extremely difficult ones. And then they can be qualitative. Those ones are based on personal judgment, or they can be quantitative, whereby you attach a value, a frequency on it, and then that frequency, you just don't get it from anywhere, but you get it from several safety standards. The simple ones would be like you have a design, and then you split it into different nodes, and then now you start identifying any hazard that might occur during operations. So that's what we call a hazard and operability analysis, or HAZOP. And then the other part might be you have a process, and now you're looking at what are the failure modes of an equipment, and then what are the effects of failure. So for example, I have put out a compressor from the system. So if I've put it out for a particular amount of time, maybe 6 months, and I want to bring it back, I will do a failure modes and effects analysis. Why? I need to understand why was it put out. That is one. Two.
Hello.
Yes.
Sorry for interruption, Engineer Matthew.
Yes.
But the presentation is not moving. I don't know if you had intended to move
Mine is
slide by
moving.
slide. Ours is not moving.
Okay. Let me reshare it.
All right.
Okay. All right then. So I was saying that if we have to put out a compressor, probably, and we've put it out. Are you seeing my screen? Is it moving? Okay.
We are now on
Yes,
slide 2.
Matthew.
Yeah. Okay. So I was saying that if you've put out a particular component, and then you want to put it back, but you've put it out for a long time, you just don't put it back because you think that by the time you put it out or you isolated it, it's okay. There could have been a degradation that happened. So because of that, you will need to carry out, you will need to start thinking about the different failure modes. Could it be on a particular valve? Could it be on a particular instrument, maybe of pressure? Could it be a seal leaking? Something like that. And then you also identify what the effects of that failure. The other part would be a bow tie. Now, a bow tie is an interesting way of identifying risk, presenting risk, identifying hazards, and then presenting management of the hazards, either through mitigation barriers or through prevention barriers. In my next slide, we will see what a bow tie looks like. But basically, you have an initiating event, and then that event, what causes it, and then what are the safety measures that can be put in place to stop the cause, or if it happens, what are the safety measures that can be put in place to reduce the severity of that. Then we have also something called a semi-quantitative risk analysis tool, which is called layers of protection analysis. Again, this one I'll explain more on my next slide. Then for the very detailed ones, these ones, we have fault tree analysis, Monte Carlo simulation, and Markov analysis. Now, these ones, you're going deep into safety instrumented systems. But to elaborate more about, sorry, are you seeing my current slide?
Yes.
Yes. So to elaborate more about what I meant by layers of protection analysis and then bow tie. So if you see that drawing up, we have a top event. So if our top event is probably loss of containment, maybe we have a tank and it loses containment, so it pours. What could be the cause of that, and then how could we prevent it? One of the causes might be overfilling the tank, but then how would we prevent overfilling of the tank? So that means we would have a high level alarm and trip, so that we know that when you reach a particular level, there will be an alarm, and if necessary, the filling procedure will be stopped, either manually or automatically. So that is how now you're identifying. And then that's a prevention barrier. So what happens if the prevention barriers have failed and we do have an incident? So do we have a band wall? So yes, if we have a band wall, then that means that the content that has been lost from the tank will be contained in a specific place. So that's what we would call a mitigation barrier. Now, when we look at the level of protection analysis, so you have this is usually done after a HAZOP. It's a bit of a very technical thing, but it looks at the different layers of protection because there are so many. We first look at the design. Have we designed it? Have we designed the system well? Have we tried to do inherent safety, or if we fail, do we have a basic process control system? Is it working? If it's not working well, what comes up? Do we have then alarms and human intervention? But then these alarms and the critical alarms and human interventions, these ones also have guiding principles on how to set them. And then do we have an idle system which only comes into play when danger has been sensed, and that's a safety instrumented system. Then so you keep on building on the different independent layers of protection. Then we do also have something else to do with modeling of fires and explosions, the risk analysis involved. So when we do all those modelings, we usually come up with specific contours, like how you see this location-specific individual risk per annum. When we get those specific contours, we now get to see and understand the different extent of a fire hazard or an explosion hazard or an overpressure hazard. Now, you would wonder whose responsibility it is to conduct these process hazard analysis and identifications. So what sometimes they don't tell us is that when you go to industry, it's all of us work as one team. So you will have a mechanical person and electrical, probably in charge of maintenance and operations. Then you'll have also a process engineer. Then you will probably have an HSE person. Then you will have those people who are only dealing with commissioning. So there's so many people that are involved, but usually it's a team because you as a process engineer, you'll not be able to identify all these hazards as a single person. So you usually have a meeting, and then that meeting you brainstorm about the different hazards. Of course, you'll be having all the data required. For example, if we are to do a hazard identification around a tank, we would need the drawings of the tank. That's one. Two, we would also need to isolate those drawings in different particular systems because the tank might be complicated when it has a filling line and then an a line that goes off from filling. Then it also might have probably heating. It might have overpressure protection. All those are things that we isolate. And then there is usually a leader or who facilitates the conversation, the meeting, like how we have a moderator here. So that moderator would be the one to facilitate such a meeting. So you identify one, the hazard, then you do the recommendations, and then place those recommendations in the design or the operating aspects. So when you now have a very clear understanding of your hazards, then you can be able to manage risk. It's unfortunate that in Uganda, most times our employers see risk management as something that is very, very costly. So they try as much as possible to cut corners because they focus more on profitability. But apart from that, one of the first things to see how to manage risk is trying to design inherently safe facilities. Unfortunately, this sometimes has a lot of money involved. So you can try to eliminate a hazard, but when eliminating that hazard makes your capital cost to be 4 times as much. So you will not be able to, it will not be wise to use that inherent safe design procedure. So then that means you have now to look at other ways of managing risk. And some of these are operating procedures. So when all of you go to industries to do internship, and some of you who've gone to places where they're operating, you have operating procedures. And these operating procedures are the ones that are supposed to guide you under normal operations, under shutdown, under emergency startups, and then under extremely very specialized parts of the processes. So that means that they need to be current and accurate. So if there is any change on the valve, then that implies that it must be stated there. So I do not expect that you go to industries that have operating procedures that were done 15 years ago, 5 years ago, and they are still being in use. They need to be updated. So within that, I'm sure you've seen that they usually have safe operating limits, and then they also have the required response in the event that you do a particular step. The other part that needs to be emphasized is the safe work procedures. So these ones are usually non-routine. These refer to usually non-routine works. For example, annual calibrations. There could be inspections and then the testings. So all non-routine work needs to first and foremost follow a detailed risk analysis. That is 1. 2, for specific works, there has to be specific permits that are given, and those permits need to be given only when the entire risk has been assessed. Then 3, the permits require to be updated in the event that work is being done per shift. So failure to do this, it can lead to a very big problem. And I've given an example here of the Piper Alpha oil platform explosion that happened in 1988. Contractors came and isolated a safety valve, a PSV, a pressure safety valve, and they wanted to inspect it. It was on one of them. It was on one of the condensate pumps. But what happened was, when they removed it, they never put it back. So hydrocarbon oil started leaking from that safety valve, and the night crew, which was aware that maintenance works had been done, it never knew whether the valve was on or off. Unfortunately, what happened was an explosion happened and 167 people died, and then there was a loss of revenue of around $1.7 billion. Now, if safe work procedures had been followed, then that particular accident wouldn't have occurred. The other aspect is now to do with maintenance, asset integrity, and then reliability. So we realize that on every facility that we do have, there is specific safety and environmental critical elements, and failure. These are very particular to do, and they deal with minimizing any severities or initiation of accidents. So failure to work on this, failure to maintain this, failure to create responsible people who have to take responsibility over this, which is one of the biggest challenges in Africa. We do have a lot of problems, and these problems are just because our reliability and asset integrity is being mismanaged. And of course, when we work in manufacturing facilities or process industries, we usually use a lot of contractors. So we need to as well ensure that contractors, one, are trained in safe work practices, but then two, they perform their roles as per the internal procedures of safety. So again, if we're to go back to the other incident that I told you about, that the contractor, one, hadn't been trained in safe work practices. But then two, even when the incident happened, the contractor didn't have adequate emergency response training. So that's why you find that so many people, and most of the people who passed on, were his own people. So now, you will ask if all these are there. So that means that usually there are gaps sometimes, and then those gaps need to be assessed. So if you go as a chemical engineer, you're going to go with a lot of book knowledge and very little experience, but the person needs to assess you first to see what you can do, to see your gaps, and then after that, be in position to train you. And then when they train you, they must assess that the training has had an impact on you. The other thing that I would finally want to talk about is management of change. So when we are in a facility, there's sometimes modifications, and then these modifications require a lot of changes, a lot of updates onto the operating system, onto the conditions, and all those are things that we usually take for granted. So you will be in a section, they are changing something, and then you do not know whether it's a replacement in kind or it is a change. But if it is a change, for example, you have one line, maybe you have a turbine system, a cogeneration plant, and then you have a very high pressure steam line first. And now you want to change the process to tap part of that very high pressure steam to come and provide process heating. That means that your entire process has changed. So you have a tapping point, and then that implies that the design of that tapping point is so different, but then also the operations of the turbines are going to be extremely different. So then what does that mean? It means that you, as a engineer in charge, you need to ensure that people, one, understand that change. Two, they also need to do training to understand how to effect that change in operations. But then three, they must also understand the hazards that are related to that. So because of all those things, you need to be extremely well versed with what is happening. Because if that doesn't happen, then you're bound to blow up your entire system, you're bound to lose people, you're bound to kill people. So with all that, then that means that we need to have always be very ready for operations. So if we're to be ready for operations, then that means that every time you put out a system or a component or an entire facility, before you bring it on board, you need to do a pre-start safety inspection. Are all the critical aspects okay? Are all valves okay? Are they all in their administratively lockable or open positions? All those are things that are required. And then above all those things, then there will be something called emergency management. And with emergency management, you're basically training people on how to handle emergencies, because when an emergency happens and people do not know how to handle the emergency, then you're bound to have more fatalities. And that was the example of that Piper Alpha. The incident happened, but the contractor employees did not have, they didn't have emergency management information adequate and skills. So you will usually see drills being done maybe, and then an incident is simulated, then a drill is done to see the response of the workers, to see the response of the community. Where I was, there's a time in 2019 when we simulated a drill of a petrol tank on fire, and we had to involve so many people. We had to involve our neighbors, GAPCO, we had to involve Vivo Energy, we had to involve multiple hauliers, we had to involve Monitor, we had to involve police. So we did all that to see how quick these people would respond if the actual emergency happened. And unfortunately, the response times were really bad, and we saw that as a gap. So we had to train them to see how best they work out the response. So all these things that I have spoken about, it is a process safety engineer, it is a risk management engineer that is supposed to handle this at any facility, whether it's oil and gas, whether it's chemicals, whether it's petrochemicals, whatever. It's your role to handle this. And with this, you'll be able to reduce your risk from very high probably to minimal, and then you continuously ensure that you monitor everything that happens. If we're to talk about maybe environmental management, again, it goes back to this, because once you have an incident, then you're affecting the environment directly. So all the things that I have spoken about not only protect people, but then they also ensure that the environments in which the plants are is what is protected. Yeah, that ends my presentation. So I'm open to any questions that members might have. And yeah, I'm glad that I've presented this. I'll be able to explain anything more in the event that you need anything to explain. Thank you.
Thank you so much, Mr. Kinyanjui. We are so grateful for your presentation. Thank you so much for sparing your time to be with us here on this platform and for honoring our invitation. Thank you so much. I will continue to thank the members that have joined us, who didn't start with us. Thank you so much for being part of us. Once again, I'm Esa Onwahereza. I'm in year 1, and I was given a chance to be the moderator today. So any person with a question, you're free to ask. So thank you so much, Mr. Kinyanjui. Thank you so much. We're so grateful for explaining to us the risks in the chemical field. Yeah, we know risks cannot be stopped, but we can control them and have them in a tolerable range. So thank you so much. So anyone with a question, you feel free to ask, and then you understand more. Thank you so much. Anyone with a question, feel free. Yes, Mr. Ethan.
Yes, thank you, Mr. Esau. Mine is a request. I request that Engineer Matthew's presentation, I request that it's shared with us after the meeting, if that's okay.
Thank you, Mr. Ethan. Any other person? Feel free. Yes, Mr. Mungfeni.
Okay, thank you very much, Mr. Matthew, for your presentation. To me, my concern comes when you are in the field, like in places of internship, and you look at a problem in terms of the safety aspects in a particular place, and you try to report, and the people you are reporting to, the immediate supervisors are not responsive. Are you allowed to skip levels, or you have to also wait for response from the people whom are not appearing to be unresponsive? Thank you.
Thank you, Mungfeni. Any other question? Feel free to ask, and then he will answer all questions at once. Yes, Joel.
Yes, thank you so much, moderator. And thank you, Engineer Kinyanjui, for the very, very, very insightful deliberation. Now, I'm wondering, you mentioned that you you carried out a simulation with Total and other neighboring, companies that you were with, and then you said the response time wasn't good. So I'm wondering, how often are these maybe risk assessments or analysis or even simulations? How often should they be done? And following the poor response time, what then did you guys do? Or at that point you have to resign and just wait for the day the thing actually happens and count the losses? Yeah, thank you.
Thank you, Joel. Any other question? Feel free. We are here to understand. Feel free to ask questions. Engineer Matthew will answer them. Yes, Musa Asizi.
Yes, good morning, everyone that is on this call. Mike, thank you very much for your detailed presentation. Mine is not a question, but rather a supplement. I'm a chemical engineer like you guys, and I'm a registered engineer with iChemy. Apparently, I've registered as an associate. I've been transferred, and I'm on my way to register as a chartered engineer. It's the journey that I've started. To supplement briefly on what Matthew presented, just to remind you that I've worked with Matthew in the past in the same area of work. My previous work was on EPC, what we call the engineering, procurement and construction, or the detailed engineering design for the Tirenga CPF, where I work as a safety engineer, technical safety engineer, where we look into the detail of the safety engineering design. And just to supplement on Matthew's submissions, for me, it's to clearly differentiate between process safety management or process safety and with the normal occupational safety that we all are familiar with in different workplaces. So process safety or technical safety incidents, we mainly look at the major hazard incidents. You will notice that when it comes to process safety incidents, they don't always happen or occur in workplaces. They may take time, but when one incident happens, the magnitude or the outcome of the incidents is always very big, where we have a lot of property damage, or even several fatalities and a lot of huge impact on the facility, on the plant. Whereas occupational safety is not that major, we tend to have a lot of occupational safety incidents happening in workplaces. So they happen very often, but then the impact is not always that much. So process safety management tends to focus much more on what we call the critical barriers. Like Matthew mentioned, we start with the scenario identification, where we identify all incidents, all scenarios that may cause incidents in a process facility. And then we look at the barriers. Matthew shared with us a bow tie, which is basically a representation of the scenarios that we expect to have on a facility. That's what we look at in detail when we are doing the detail engineering. Look at the scenarios and events, anything that may lead to incidents, and then put much more focus on what we call the critical barriers. What do we have in place to prevent, control, or mitigate these scenarios from happening? And that's the bow tie Marshall was presenting, where you have the incident pathway that shows what can cause the incident. And then on the other side, you have what we call the escalation barriers. If you have the incident, what do you have in place to manage the incident actually from happening? So for me, it's I don't want to go deep very much of the time. I want to appreciate Matthew and all of you, and whoever organized this. It's a good one where we share and get to learn from each one of us. Thank you, and back to you, moderator.
Yeah, thank you so much, Engineer Ferdinand Musasizi, for also spending your time and joining us. We are always grateful when we see Kyambogo students making it. We also gain hope and courage that we are also going to reach and make it in the future. Thank you so much for always sparing your time, coming and inspiring us. We are so grateful. Thank you so much. May God bless you abundantly. So, Engineer Matthew, the floor is yours back again to answer the questions. Then we receive the next speaker. Thank you so much.
All right.
Engineer Matthew.
Thank you, Fred, for enlightening us more. Maybe let me first answer this. I'm saying Aaron has a question, but the first one was for Peter, who identifies specific gaps in HSE, and then he tries to report to unresponsive people. Unfortunately, that's the culture that we do have quite often in Uganda, that the person who's supposed, the HSE superintendent sees things and they just take them for granted. You as an intern, you might not have a lot of say because one, you're just an intern, but then two, I am very well aware that when you go for internship, you're not given insurance, health insurance, so you're not insured. So that means that you have to be extremely careful. If you're seeing that the HSE team is not managing those occupational safety hazards, try as much as possible to avoid being in line of fire. It's one thing to report to the boss, but the most important thing that I would advise is try as much as possible to be out of line of fire. Because if an incident happens, then it's you who is affected. The second one was about how often do we do drills? How often do we do risk assessments? The UK law stipulates that for any major sites, they call it tier 1. Okay, so those ones have lots of hazardous events. We do an audit, an annual audit on the process safety management. But then after 5 years, we do what we call a revision to the risk assessments or the major risk assessments. And that's also within our law, the Ugandan 2 laws on oil and gas. One is for HSE upstream 2016, then the other one is for HSE midstream. So they require a detailed risk analysis to be updated after 5 years. So when it comes to that, can be 5 or it can be wherever there is a major change on facility. For example, if you have a sugar complex and now you're changing that sugar complex from you're increasing capacity, so that means you must update the risk assessment. You must update literally all the risk, all the safety studies, the QRAs, the FERAs, the EEAs, all those you must identify them and update. Now, regarding drills, this is usually an inside thing that all of us have our employees have management principles that guide them. Where I was, we would do a drill every month to test, but those would be small drills, and every after 3 years we would do a major drill. So the smaller drills, the monthly drills, were something tiny, maybe a gantry has fire, so you go respond and we were just building internal capacity. But for that particular one, when we had to involve other stakeholders, it's because we were simulating a drill, a fire on a tank that had 7 million liters of petrol. So that means that we cannot do it alone. Vivo has to, because it's our neighbor, monitor, fire brigade, all those are supposed to be there. So even in different industries, you find that you have different schedules for doing the drills. Thank you.
Thank you so much, Engineer Matthew. We are so grateful. Thank you so much. Let me take this opportunity and hand over to my co-moderator to take over.
Yes, thank you, Mr. Esau. And he was a student at Chambogo. So, ladies and gentlemen, engineers, students, join me as we welcome Engineer Ogwang Ambrose to give us his speech for the day. Thank you. Engineer Ambrose, the floor is yours.
Ethan, can you hear me now? Hello.
Yes, we can hear you.
Okay, so I will share my slide. Minded. So for those that do not know, the name of our association was derived from the word ace. To ace means to be an expert at something, to excel at something. So James Chowell came up with that idea with the name ace. He was like, why don't we call ourselves aces? That means experts, and it fits in well for the acronym Association of Chemical Engineering Students. So we're happy to have James Chowell on the call as well. And we also have Gideon Omoding. But at the end of this all, Dukumaiko will say something on behalf of my colleagues. Are you all with me on the second slide? Hello, can you still hear me?
We are still
Yes, still on the first slide.
I guess there is a lag in network. Is it, has it changed now? Can you see the second slide?
It has not yet changed.
Oh, let me try to share again, because for a very effective presentation, it would be good if we move together on this, because I have some videos I prepared, and so let me know when it changes.
It has changed. We are now on the second slide with you.
Okay, so just briefly, that is my profile. You asked me to reintroduce myself. I'm called Ambrose Ogwang. As I mentioned, I'm currently working as a drilling engineer with CNOOC. CNOOC stands for China National Offshore Oil Corporation. For my education, I hold the Master of Technology in Petroleum Exploration and Production, which I acquired from Dibrugarh University in India. That was in the years 2018 to 2020. Currently, the name of this course has changed. You people are here, it's now Chemical and Process Engineering. Well, we were the pioneers of this course. By then, it was just a Bachelor of Science in Chemical Engineering. The process engineering aspects were not so much emphasized as they are today, but this is also good. It shows part of the transition journey. So I did my chemical engineering in Kyambogo, were the first lot, were the pioneers. We didn't have references. By then, it was only in Kyambogo and Legia University. It has now spread through. And then for the work experience, I've been in the field for about 10 years now. As the moderator mentioned, I was a core member as part of the team that established ACES in 2013. The core team, about 5 of us sat down and we came up with an idea to form an association that fits with us, because we did not see any. There was a Chemistry Technology Students Association. By then, chemical engineering was under the chemistry department, but now I'm happy that it is under engineering department. So we formed our own association then, and as a result, I served as the inaugural president for this association, 2013-14. That is when we formed this association. Then I also served as a petroleum engineering consultant with a Sigma Advisory, production engineer with oil and natural gas, that's state-owned in India, petroleum engineer with the Arab Oil and Gas Academy in the USA, and I also worked as a reservoir engineer with Hindustan Oil Exploration Company in India. And prior to that, before going to India, I worked as a petroleum quality analyst, the fuel marking program. And yes, like all of you, I started my journey through internship and training. So I did 2 trainings. My first training was at the Ministry of Energy and Mineral Development. We were designing the refinery, we were doing the current works. By then, I was under the mentorship of Irene Bateve, who is now the permanent secretary. By then, she was a principal commissioner. And my second internship was at UNBS in the Petroleum Standards Department. So that is briefly about me. Has the slide changed to the next?
Yes, it has changed.
Yeah, we'll have an interactive session just to make sure we don't leave anyone behind as we go on. So I'm just going to look at 2 topics, professional accountability and innovation and intellectual property. I'm going to keep my presentation very short so we have more time to discuss and have a few questions. Has the slide changed?
It has not yet changed.
Okay, as you're waiting for it to change, I'm working in the oil and gas sector. So in the oil and gas sector, safety is very key. before we actually have any presentation, we have what we call a safety moment. This is because we believe in a system of having safety first. A safety first culture creates that awareness. We want to have an environment where if you have any incident, you can stop work immediately and report. So I'll start my presentation by taking us through a safety moment, just to give you a feel of what happens. I'm currently working in the oil and gas industry, so my bias is more in oil and gas industry, which is good. We had a presentation from Matthew, who was more inclined to the process safety, process engineering. So this will give you a good balance. I believe there are some of you who are doing the course and you're interested in joining the oil and gas sector. So maybe you can pick a thing or two from here. So are you on the next slide?
Yes, we are.
Okay. So my safety moment comes in reducing stress in the workplace. As you work, when you join the work sector, you're going to experience so much stress. You can be overwhelmed with stress. I believe even as students, sometimes you get stressed. You have lectures one after the other. You have assignments and coursework. This can get overwhelming. So it is essential that you know how to manage stress in your day-to-day life. So these are some tips of how you can manage stress in the workplace, and I believe they also apply in your university setting. So try to get 30 minutes exercise on most days. Get off some time to exercise. This is good for your body to help you ease out. Ensure that you eat well. Have a balanced diet. Have a variety of meals. Try to have fruits, vegetables. This is calming and relaxing for the body to help you keep your stress levels low. Find a balance between work and your leisure time. You could get an activity, a sport that you do, maybe playing soccer, basketball, tennis, jogging around, hitting the gym, whichever works for you, but get something. And when you do, strike a balance. Don't read all through from morning to night. You'll burn out. Take off some moments, take off breaks, health breaks. It is unnecessary. Then you can have someone that you confide in. You speak to them and share with them. This helps control stress. Then ensure to have a full night's sleep. A full night's sleep is recommended. Science recommends about 7 to 8 hours of sleep every day. I know when exams come around, very many of you are always awake through the night, but it is good practice. Have a good night's sleep. This will improve your performance and keep stress levels low. Then endeavor to do your best and think positively, both as you go through your day of work. Are you with me on the next slide?
No, not yet.
Okay, as it is loading, for the next slide, I'll be delving into professional accountability. As I said, I'm going to keep this presentation very simple and quick so that we have more time to interact and engage. So moving on to professional accountability. Can you see the one with professional accountability definition?
We are not yet there, but you can. I say we can continue as it gets there.
Okay. So what is professional accountability? Professional accountability is the act of being responsible for your actions and decisions and being able to explain them apparently. So when you join the oil and the working field, you have to be accountable for whatever actions that you do. You'll get assignments to do. You have to be accountable. There's a reporting system. You'll have someone that you report to. So it is essential that you're accountable for your particular tasks. So what's required of you? You have to be responsible. You have to be accountable. And you have to be answerable. That is why very many companies prepare reports after every task. You have a small report presentation. This is part of accountability to update on what is happening. So this goes quite a number of ways. You need to have values, morals. You need to be responsible. Yeah, so this is just briefly a definition of professional accountability. Can you see the slide, the next slide?
We cannot yet see it.
Okay, as the slide comes, I would like to highlight that professional accountability is personal. This is it's a personal initiative. You need to take it upon yourself to be personally responsible. So from my work experience, I've been in the field for about 10 years now, but these are the key factors that I've seen that will make you accountable. They will make you grow through and excel in your career. If you can master these, you'll have a very successful journey wherever you'll end up in life. But if you follow these principles, these I've personally seen, and I would attribute quite a number of them to where I've gotten up to the place I am today. Number one, show up to work on time. That is very, very key. Time management. I'll give an example of this webinar. We're meant to start at 10. I logged in a few minutes to 10, and surprisingly, the people I found on the call, I found Engineer Mpuga Henry, I found Engineer Matthew Kinyanjui, and I happened to find Engineer Norbert Vitas. These are the people that are in the professional world. They were the ones that logged in before, the students, and this was a very bad example. We should have started at 10. I logged in 15 minutes too, and I found these people. Then the meeting was pushed to start at 10 minutes past 10. For starters, in a professional setting, that's already a minus. If I were in the recruitment committee, I would, if I was hiring people and this is something I was looking at, I would definitely say your time management is poor, so I cannot entrust you with more responsibility. So try to adopt a culture of time management. If the meeting is started at 10, log in 15 minutes to 10. If it is 10 for the moderator, you start. Whether you have one person or two people, that is the principle. The rest will always join in. That's something that works in the professional sector. If a meeting is scheduled, because time is money, time you waste, you're costing the company money. So when you're meant to deliver on a task, be strict on the time. So this is something that we can all pick from. I have seen our response. I just logged in to observe and I saw very many came in later. If you carry this attitude when you join the professional sector, it's going to affect you. So try to polish up on this. Then deliver your assignments on time. You're going to be getting assignments. You can do an assignment, but when you deliver it past time, your boss will not be impressed with you, and this will affect your performance. So it is essential. You will get assignments and you deliver them on time. Then put in a full day's work. If you're meant to work from 8 to 5, let it be 8 to 5. I see quite a number of you have a culture when it's Friday and it is 3, 4 p.m. People start saying to UK, well, in the professional setting, that will give you a negative score. So if it is putting in a full day's work, be available. That makes you reliable. Then communicate clearly and effectively. If you have a scheduled meeting and you cannot make it on time, communicate in advance. This will help you. Other than making assumptions, then be interested and involved. Show initiative as you're interested. You definitely pick, if you're a supervisor and you have a team member who is interested in doing their work, you don't have them everywhere. Then be self-driven. Don't wait to have your supervisors tell you what to do. Have the self-drive. This shows the initiative and they'll then trust you more. And above most, keep learning. Never stop learning. Don't think once you have your degree or you go ahead and do your master's, that is good enough. Keep inquisitive. The world is always evolving. So there are some habits that you can adopt. Don't blame others. Look into the mirror and try to engineer the solution. So there are quite a number of good performance ethics that you can take on. Focus on your work. Be dedicated. Self-discipline. Time management, as I mentioned. Be dependable. have the initiative, be goal-oriented, and be responsible. These are just some of the key pointers that I can mention. Moving on to the next slide. Why is it important to be accountable in the workplace? Just to confirm, can you still hear me?
Yes, we can hear you.
Okay, are you on the slide? Okay, I'm on the slide of how to be accountable in the workplace. Are you with me on that?
We're not yet there on the slide, but we can hear you.
Okay, I guess you will get to join me on that. But for the sake of time, managing time effectively, I will go on. So what are the benefits of accountability in the workplace? Number one, there is improved performance because you manage tasks on time. For example, now it's almost midday and I just started presenting. If we had managed our time better, Matthew would have had an hour and I would have also had my hour, but because we started late, so it affects the performance. Then it encourages enhanced communication. It builds trust. There is increased trust and there is better decision making because everything is transparent, and it creates employee satisfaction in what way? If you perform well, you'll quickly rise up the ladder, you'll get the promotion, benefit. So it is something that you need to carry on. And some of the problems caused when you do not lack accountability, low quality work. For example, now if I'm presenting, I'll be cautious of time, I'll rush through, and I'll not deliver the quality that I should have delivered if I had sufficient time. Decreased productivity, high turnover. That means if people are not satisfied with work, they'll keep leaving, coming in and going, which ultimately affects work performance because you have to keep training the new lots. Then employees get disengaged and there is low morale. So moving on to the last segment of my presentation, I said I'm going to keep this short so we can have more time to interact. I'm going to look at innovation and intellectual property. I hope you're with me on that. So talking about innovation and intellectual property, just to define what is innovation. Innovation is a new idea, method, or device. As simple as that, or introducing something new. It could be a way of improving a system that you already have. That would all be categorized as innovation. So the other question is, what is intellectual property? Intellectual property is that intangible property that you use to protect your innovation. It is basically after you come up with an innovation, an idea, you try to protect it from someone else using it, from a breach. So that is intellectual property. You protect it from your competition, from anyone else using it without your consent. So it is basically a way of protecting what you create and to have the full benefits of it. So intellectual property involves things like copyright. That means you have exclusive rights to use your innovation. Patents, someone cannot sell your idea or reproduce it and get money without your permission. Inventions, trademarks, these are all categories of intellectual property. So what are some of the benefits of innovation? As you can see in this slide, there is improved productivity because as you innovate, you come up with the whole idea of innovation is to come up with quick and seamless ways of doing things. You try to improve a process, so that ultimately improves our productivity. There's increased competitiveness, which is provided as a result of innovation. It brings on board new partners and relationships. People want to fund ideas. There's funding that comes on board. Everyone wants to partner with something that is doing well. So this builds collaborations. Ultimately, the objective of innovation is to reduce costs, try to keep costs on the low. Then it gives you a brand recognition and value. You build a brand and you know this helps you penetrate the market. And there's increased turnover and profitability. That means if you're producing, say, 100 units of a commodity in a day, if you're able to innovate and make them 150 in a day, you have a high turnover and you have a higher profit margin. Moving on to intellectual property. As I mentioned, intellectual property is basically protecting your innovation. So why is it important? Number one, you get to protect your moral and economic rights. It protects the moral and economic rights of the creators. You protect what you've created from someone else using it. It promotes creativity as well because you know there are benefits attached to it. Then it encourages fair trade. You create a platform of fairness basing on the available tools. Then ultimately it contributes to economic and social development. So moving on to, you people are chemical engineers. I believe you're wondering what can we do? What can we innovate in? How can we impact the world? There is so much. As I mentioned, these are personal things. But I'm just going to give you a few examples, some sectors and some of the emerging technology that's happening. For example, we have artificial intelligence. Artificial intelligence, basically, we are using robots to think and do what the human mind would do. That's an example of something that's happening in innovation. It has taken a grip. You've heard of the Internet of Things. Internet of Things is basically how you're able to communicate through the internet and link different devices and communicate. For example, I'm making a webinar to you and I'm not there with you. This is an example of innovation. Back then, I would have to travel to Kyambogo University and meet you physically. So we are actually benefiting from something of innovation. Then we have blockchain. So blockchain is basically a system that stores information, basically coming in from cryptocurrencies and connects them to computers in peer review. So you find different computers are interconnected and they're trading in things like cryptocurrency. This is an example of blockchain. Some people have built fortunes from that. Notwithstanding, some have burnt their fingers, but this is just to show you all these effects of innovation. Then we have quantum computing. Quantum computing basically involves computers using quantum mechanics to solve problems. As chemical engineers, I know you've studied something about quantum theory. You know how the quantum theory works. So computers try to adopt the quantum mechanics in solving problems. This makes them work faster than the conventional computers. These are all examples. Then talking about the energy sector where I'm working, you've heard of the renewable energy. The world is moving away from oil and gas. We are transitioning to renewables, wind, solar energy, biomass. These are, you've heard of the electric vehicles. So this is all an example of energy transition that's happening. So you need to keep alert as you study what's happening in the world and see how you can be relevant. You don't want to be in a situation where the world has evolved and the knowledge and skill set you have is not adapting. That's why I told you keep learning and improving yourselves. Then we have 3D printing. So 3D printing is basically reproducing something using 3D views. So you basically pile different sheets and you come up with images. So that's you come up with something from an orthographic 3D view. So people are getting to produce a lot. So there's a lot that is happening. Then we have augmented reality or virtual reality. This involves superimposing an image. For those of you that have tried virtual reality, you get to wear that virtual reality to cover you and you feel like you're in another place. You look around your surroundings and it is all different. This is all technology. Then we have autonomous vehicles. These are vehicles that can be driven without human intervention. These are just some examples. I'm just trying to spark because the world rewards innovators, people that are able to come up with things. There's a lot that you can do, but this is just to try and spark you. So briefly, just to highlight on the innovation process, it has 3 steps. You understand, you see a problem and conceptualize it. Always starts in the mind. You generate the idea and then you deliver. So in your mindset, you need to first internalize the problem, see what you can improve, what can you come up with. Then you need to conduct in-depth research, make sense of the data. You may need to reframe it and redefine. But as you do this, you need to be impact-driven, focus on solving a solution, and you need to have multiple iterations. So you have an iteration, then you choose the best working solution. You may have like 10 prototypes, 10 different types, and out of the 10, you'll choose one that works best. After that is done, you go to the generation of your idea. So this involves you set up your prototype, you test and refine it, and you keep polishing it up to get the very best. Then you deliver. So delivery involves making a pilot delivery of your project. You track progress and you continue improving on this. So some tips I can tell you personally that I've mastered and seen in my journey that can help you with your innovation. Have a starting point. You can't start innovating out of the blue. You may see a process, for example, how a lecture is being delivered in Kyambogo University. Do you think you can improve on that? Is the information storage good? What can you do to improve on this process? Something, you just see something and sparks a thought. Then number 2, dream. Don't stop dreaming. Most of the innovations that we see all started with a dream. Someone had a dream about something. Don't rubbish your dreams. When you have a dream, go study, dig deeper. Everything always starts with a dream. So don't stop dreaming. Dream and dream big. You never know what turns out of your dreams. Then value solitude. Most innovations come when you're in a place of quiet, when you're meditating, when you're thinking through. So have those moments to ponder through life. Sometimes you get carried away. You have lectures one after the other. You have assignments, and you never have time to reflect. So try to have some moments where you have your alone time. You meditate. You ponder on life. You study what is happening. In there, you never know. Something can be born. Then be diligent in what you do. Diligence is careful and persistent work. Be consistent in your work. In there, you learn so much. You master the principles and patterns that govern innovation and success. So as you do, you get to learn so much. Then connect with what's on the inside of you. We are different people, are created unique. God has deposited something unique and different in each one of us. Instead of trying to copy other people and be like them, look inside you. You have something deposited in there. Try to stir it and bring it out. All this will help you in the innovation journey. Moving on, I need to make sure you're on the same slide with me because I just have some case studies to show you, and I will be concluding my presentation. Case studies in the oil and gas industry. Can you see, are you on the slide with a video?
We are not yet there on the slide with a video.
Okay, you'll need to watch this video because I'm trying to show you, like in the oil and gas industry, I'll show an example of innovation that has happened. When you are on that slide, you let me know. So just to give it context, these are roughnecks. Who are roughnecks? Roughnecks are guys that work on the drill floor. They do the connection of pipes and make sure everything runs well in the hole. So back then, before the innovation industry picked up, this work was done manually. As you're going to see in this video, guys would they always wanted strong guys with so much energy. If you'd look at a job description, they would be asking ability to carry a certain weight. So work was very manual and slow. But with the current innovation, the system has been automated, as you're going to see in the next video. Can you see the slide with the video now?
Not yet.
Okay, it is essential that you see it because it's going to give the tone of my case study. Which slide are you seeing?
We can see the slide. You can see a slide. I think we can see the slide with the video.
Okay. So I'm going to play the video. I do not know about the response time, but just to give it context, this video shows you how roughnecks used to work back then. This was taken This video is about 4 years, about 2019. Is the video playing on your end?
No,
It's not yet playing.
it's not.
It's not yet playing.
Not yet.
Wow. It's actually, it's almost coming to one end. Let me try to use the app and see. It would have been essential that you see this video because it would highlight a case study about. What are you seeing on your end now?
We're just seeing slide with the heading of innovation and intellectual property. Then there's an image with a caption saying video showing manual pipe handling system work
It's
procedure.
unfortunate that the video is not, you cannot see the video. Probably I'll share the content and you'll get to view it later, but in that video it shows how pipe connections were made, and the next video shows how we currently make pipe connections. It would have been vital for you to appreciate this. Is the next video playing? How about now? Can you see anything?
Still nothing yet.
Okay, maybe I think we have a lag, but basically what I was trying to show is connections were made manually then on the drilling floor, like during drilling operations, and now we are doing them automatically. So I had two videos, one showing you how it was done, and now the current showing you the current situation. Probably you'll get to see the content later on. I will share the slides. How about which slide can you see now? Can you see a slide with an aerial view of the site?
Not yet. We're still on the previous slide.
Okay, I guess I will.
We can see it now.
Okay. Okay. Now that's our site. That's our site. I just wanted to show you, like, have a view of what it looks like. As you can see, we are drilling very close to the lake, so we are very cautious of pollution and very cautious of pollution and protecting the environment. But I will get to share these slides with you, and maybe you can we can discuss more. Yeah, but basically that's it for my presentation. It's unfortunate the videos have not played, though they had something to show, but I can before I take on any questions, allow me just in 1 to 2 minutes, call on my colleague to say something. The one I told you about, Michael, Duku Michael, is in charge quality and safety Trinity Energy in Sudan. He was part of the SS committee as a legal advisor. So he can just share something in 1 or 2 minutes, and I'll be able to take on any questions that come. On behalf of my other colleagues on the group, Michael can say something.
Well, thank you. Can you hear me?
Yes, we can hear you.
Okay, let me just try to put face to this. See. So, yeah. Thank you, everyone. As my colleague has said, my name is Duku Michael, and I was part of that group, the pioneer group of chemical engineering students at Chambogo University. Ambrose, I can see James Joel Semakula, and then I was told also Sarah Nyangoma is here with us. So thank you so much. As already mentioned, I was part of that group, the first lot of chemical engineers from Chambogo University. And Ambrose was our first president. If I remember, if I can recount so well, maybe I think I was the one who nominated him. Unfortunately, he went on to get the position, I think unopposed, if I'm not so mistaken. So Ambrose, congratulations, you did a good job. You raised the bar so high, and then our members are now taking it even higher than what we tried to do. So yeah, when we completed, life as a student is quite, you have a way of thinking. So Mr. Kinyanjui, Engineer Kinyanjui has given us the technical presentation about safety, about process safety, and then Ambrose gave us the soft side, which is mixed with the technical side of his work. So I'm not really going to talk much about that, and thank you guys for that good presentation. After my degree, I went to the University of Dar es Salaam, where I did oil and gas technology, and soon after that, I managed to go to Nagasaki University in Japan, where I did environmental engineering at the Graduate School of Engineering, Department of Advanced Engineering. So when I got back, my first assignment was I was contracted by the Ministry of Petroleum, where I was a lead auditor in environmental audit. So we are doing an environmental audit in the oil fields, which I completed in about 14 months. And now that report is now with the ministry, and now they're doing the presentation in the National Assembly. So when I completed that task, that's when I joined Trinity Energy as a quality and safety officer. So Mr. Engineer Kinyanjui was really talking about more or less my daily activities at work. So what I can say is mine is just, I got to know about this webinar just last evening. And I don't have a presentation to give you, unfortunately, but I just want to maybe advise. As a chemical engineering student, there is a way sometimes you are taken into some deep kind of thinking. What will I do after this? You can go around, you check Google and so on, where do chemical engineers work and so on. But you seem to be asking yourself questions every time and then, which is normal. But what I can say is what is expected of a chemical engineer, just like any other profession, if I may say, is as chemical engineers, you have to be thorough. I mean, by being thorough, you don't have to know everything, but the little that you know, make sure you can really, explain it to somebody and they understand. So what do I mean by that? When you say you're a chemical engineer, someone already has put you at a level by saying that. You'll find they come to you, seeking for advice or, bringing problems that they expect solutions from you in the workplace. So make sure when you respond to such, you respond with facts, and then you are able to explain everything in a way that that person can understand. You have to keep calm. I mean, you are given something, a task, and then you just want to complete it, faster, or you want to give your opinion faster, and then you find yourself, you have not actually answered all the questions you are supposed to answer in your statement. So what I would advise is, as chemical engineers, it's good to desist. It will be good to desist from issuing statements that are more of like, perfunctory in nature. So when you're giving your opinion, before you say something, just try to answer all the questions that person can ask you from that statement you're giving out. So once you do that, one will have this feeling that, yeah, this person knows what he's doing, and that is all what they want in a workplace. From my experience, all these employers, they know that you don't know everything. As Engineer Kinyanjui has said, it's 90% or 80% of what we do, we actually learn on the job. You'll be surprised when you come here, you don't see the thermodynamics like practically, but it's going on, but it's not your daily thing. You don't see the engineering reactions and so on. So it's just about doing what you know in a way that is presentable. And don't fear to say, for this one, I don't know, like this, I cannot explain this, I need time. So don't shy away from some of those statements. If you cannot, complete a task within the time limit given to you, you need to better request for more time or try to make adjustments in consultation with your boss, so that you don't do work that is questionable. Someone comes and says, this is not what you're supposed to have done and ABC. So basically, that is what I can tell you. And also on the soft side, when you're at a work environment as a chemical engineer, you are a busy person. You are thinking about big things. You don't need to engage in, petty kind of office politics. As an intern, you go there and you hear people saying so and so is like this is like this one doesn't know that, all this. So some of those allegations or insinuations that are kind of frivolous, don't engage in that, because once you do that, someone has this feeling that maybe cannot handle big tasks. That's one of the examples. So I will advise that just focus on what you're doing, because all of us, we know what we want. So when you focus and you do your part, pray about it, and then be consistent. At the end of the day, you get where you want to. And the last one maybe is don't have a very fixed I need the money, I need the money. And they go out there in the first year after graduation, they have an opportunity to go for further studies, they have opportunity, but they're like, no, I can't go back to school now, I need to make the money. So you try to be flexible, so long as you have a target and there is a way of reaching that target, even if it takes a little bit longer, so long as it's the right thing to do, please make sure you take those opportunities. With that, I would like to say thank you so much to the organizers, and on behalf of the colleagues of our first president of SS, I would say that Mr. Engineer Okwang Ambrose has our contacts. So in future, I will suggest you kind of give this information to him quite early so that he can share with us. And we shall also be able to, do more than what we are doing now. And since we are brothers and sisters of the same profession, there is a lot for us to share. So thank you so much. I hope I've been audible enough. Yeah, thank you.
Yes. Thank you, Engineer Duku Michael. It's really heartwarming to see that the people ahead of us in the same profession, they take time to come and talk to us, to be an inspiration. Thank you, Engineer Ogwang Ambrose, and ladies and gentlemen, at this moment in time, so if you have questions for Engineer Ogwang Ambrose, this is the time. Thank you. Yes, Miss Sanyu.
Good afternoon, and first of all, I would like to really thank Engineer Ogwang Ambrose for all the insights he has given us. The question I have is about the copyright. When a student like me has a project or an innovation, how do I get the copyright? I want him to take us through the procedures on how to obtain those copyrights. Yeah. Yes, and I could really thank also the previous speaker for showing passion that also the alumni are passionate about coming on board to help us who are going into the sector. Thank you.
Yes, Miss Lois, the floor is yours.
Good afternoon, everyone. My question revolves around Mr. Ambrose's working experience. I would like to know how they do the fuel marking and quality monitoring, because it seems I would like to do my project relating to that. Then another question is, how do I develop standards? Because I see a trend in UNBS about standards. Maybe for the new standards, not the old standards, the new standards. Thank you. You are.
Yes, Engineer, yes, Mr. Mungufeni Peter. And we'll have two more questions. Engineer Mr. Mungufeni, and then one last.
Okay, thank you very much. I would like to appreciate Mr. Ogwang and the other alumni for coming in. I really appreciate the effort. Actually, I can say I'm one of the happiest right now. Maybe from listening to Ogwang, should I say the history from when he did his internship. He went to the ministry, it was oil and gas. When he went to UNBS, it was still oil and gas, and he's now in the oil and gas field. How, and maybe they should help us understand the procedure, maybe how they were able to access these internship places. Was it because the competition then was low or high, or it was like the demand for chemical engineering was high, like something like that? Because you apply for in like 6 places and you find you don't get in the 5, and the list that you expect you never wanted to go to is where you have a place for internship. So how do we go about that? Thank you.
Yes, thank you, Mr. Peter, for your question. And one more question. One question for Engineer Ambrose. Okay, as for now, allow me to invite Engineer Gwang Ambrose back to answer those questions that have been raised. So, Engineer Ambrose, the floor is yours. Thank you.
Thank you, Ethan. So, taking on the first question about copyrights, how does a student get copyrights? Well, one thing about copyrights is you have to register. In Uganda, we have the URSB, Uganda Registration Service Bureau. So this is a body that is mandated to handle any such. You have to register yourself with the Uganda Registration Service Bureau. So if you come up with something and you want to have it registered and copyrighted, you do that with the Uganda Registration Service Bureau. Then speaking to your bit of innovation and technology, you can get to do some work with, there is a body in charge of science and technology, Ministry Science and Technology. They handle this bit of science and technology. So you work hand in hand with them. The whole point is that you are registered. It doesn't help you coming up with something, then you assume that it is copyrighted to you. You would have to formally register it in the system. It is when I'm sure they have their system and policies that will take you through. When you go through with all that, it will be easy for you to stand and hold your ground. I can give you an example. I'm not trying to be political. I'm not so much of a political person. But if I've had, you remember the transition of People Power. People Power was registered. It was a registered name by someone else. So when the People Power group wanted to take it on, they found it was already taken. So they had to go and use the National Unity Platform. I'm not trying to be political, I'm just giving an example. So once you do that sort of registration and you benchmark, you get to secure. Then moving on to the second question about fuel marking and quality monitoring. How is it done? So how fuel marking is done? Currently, Uganda is importing the fuel it consumes, that is petrol, diesel, and BIK. BIK would be kerosene. So the way it is done, fuel comes. We are getting it, comes in from Kenya. So when it comes in through the border points, Mombasa, Malaba, Mutukula, various border points. So when the fuel comes in, the fuel marking program has a team of people that puts marker. Marker. What is marker? Marker is a chemical that is not traceable. They pour a marker into that fuel. What is the essence? To show that this fuel, they first test it to see is the quality good. They run a quality test on it. That means they check density, initial boiling point, final boiling point. They check all those parameters. They do a distillation for the petrol, diesel. When it is good, they check does it have any additives. They check the flash point, octane number. So once it passes and it is fit for use in motor vehicles, then they mark it. So that's where the name marking comes from. So they pour a chemical. So why do they do this? Because we have a tendency, someone can bring in fuel, it is coming from Kenya, and they tell you, I'm sending this fuel to DRC Congo. So I'm just driving through Uganda. So such a person should not pay Ugandan tax, but he should pay tax in Congo. So now, how will you trace? This person may come to Uganda in the night and offload that fuel somewhere in a petrol station. That is something that we call dumping. That person would come and dump. So fuel marking traces dumping. So fuel that is driving through is not marked. So the quality team moves around every month. I don't know if Vitas is here. Vitas is a former president of, he was the SS president in SS 2022-2023. Is actually currently working with the fuel marking program. So him and his other colleagues move around every month. They visit all the petrol stations in Uganda. In a month, they check, they pick samples of fuel and they run tests on them. They run an X-ray through. So they check for that marker. If the concentration of that marker has reduced it shows that that petrol station owner added something. Probably he added unmarked fuel to it. That is one thing. Marking also controls adulteration. So some petrol stations, you'll find, for example, petrol is going for 5,000 Uganda shillings. Kerosene is normally cheaper. You find kerosene, a liter goes for around 2,800 Uganda shillings. So if a petrol station dealer has 10,000 liters of petrol and is selling each at 5,000 a liter and he wants to make more money, he can dilute kerosene. He will say, since 10,000 liters, I can put like 1,000 liters or 2,000 liters of kerosene. So I have 12,000 liters. I have a larger volume and I sell it all as petrol. I'll make more money. So he will make money indeed, but to what end? The customer that is going to come and put petrol in his vehicle will have issues because it is adulterated. The quality is affected. So how will you know that a petrol station owner has adulterated his fuel? You check for marker. So kerosene is not marked. So when you dilute kerosene, the concentration of the marker will drop below the permissible limit. So you can be able to tell. So basically the fuel marking and quality monitoring program, as the name says, they mark fuel, then they monitor the quality around the country. Then they also handle customer complaints. For example, someone can you go to a petrol station and buy fuel, then your car breaks down. Then so who are you going to report to that have consumed bad fuel? You come to the fuel marking program and you say, I fueled from these guys and my car broke down. What shall we do? We shall pick a sample from your car and run tests on it, quality, check the density, check if there's anything that was added to it, then penalize those guys. They give you, they compensate you and we penalize them. We seal them and you find they publish such petrol stations. These ones do not have good fuel. Every now and then they publish them. Hope that gives you a picture of the fuel marking program. Then how do you develop standards? So I was working with the Uganda National Bureau of Standards. That is the body legal national body authorized to formulate standards. Each country has a standards body and we make reference to the ISO, International Standards Organization. So some standards are adopted from ISO, and normally you'll find it will be such a standard will be like Uganda Standard, UEA, Uganda Standard, US, :IOS. If you say standard reference like that, it means it's reference to the ISO standard. Some standards are adopted from the East African community. So such a standard will have US, Uganda Standard, :EAC. So some are adopted, you just copy it the way it is, then you modify a bit. However, some standards are created from scratch. So what is involved in a standard? The standard is a document. It highlights, for example, I can have a standard for a pen. So it has a scope of work. It will have the dimensions of the pen, the quality of the ink, the texture. So it goes and breaks down all the different components. You can go online and download some standards and see what a sample standard looks like, but it has all those. It has annexes. So when you're formulating a standard, as Uganda National Bureau of Standards, for example, if you're formulating a standard for serviettes, you need to call all the Ugandans, let's say mattresses. You're formulating a standard for mattresses because you have 10 companies in Uganda manufacturing mattresses. Who is going to check them that is your mattress fit for use for Ugandans? Does it meet our minimum criteria? That's what the standards body does. So before they formulate a standard for mattresses, they'll call everyone supplying mattresses, all those companies, and they sit in what they call a technical committee. So they sit down and they build it together, having input from those guys. So those guys will set their minimum specifications. For example, it must have a minimum density of this. It must have a minimum thickness of this. It must have these and these chemicals. So they all agree, then they formulate a standard that everyone can meet. So I similarly formulated standards for petroleum. By then we didn't have the Petroleum Authority, we didn't have the Uganda National Oil Company. That was around 2014. We had only some of the oil players, Total Energies, but then we had Talo. So we're formulating standards for some petroleum companies. For example, standard for Christmas tree. A Christmas tree is a device that controls pressure on the drilling, like you put it on top to control the pressures, because as you're drilling, there's so much pressure underneath the subsurface. So you have to control all that pressure. So something that you put on the surface has to have a pressure rating. For example, Christmas tree must have a minimum pressure rating of 5,000 psi, that's pound per square inch. I believe you're familiar with those units, being chemical engineers. So then we test, does the pressure gauge, then pressure gauges, they have to meet this minimum specification. They have to make this number of tons. Then so that is how standards are formed for different products. You call, so when we're formulating standards for petroleum, we would call Total Energies, the players, and then we formulate and reference to the international standards. But you as a student cannot formulate a standard because there's a standards body, unless you're going to partner with the Uganda National Bureau of Standards, because after formulating it has to be registered. So you can partner with them, and maybe they could consider looking into it and adopting it, but they have a template they follow. Then how are we able to access, or someone asked how we're able to access internship. When you asked that question, Duku Michael was someone I studied with. You asked how is it that me personally, I'm in the oil and gas industry. Well, you as an individual, it starts by you as an individual. What do you want? I mean, oil and gas industry. Matthew, yes, he's in more process safety. Michael is somewhere else. James Joel is somewhere else. So it depends. Number one, what do you want? Then you asked, did we have these opportunities as they are now? Actually, I will tell you it wasn't that much, because I find it easier for you guys now. Personally, me and Mike wanted to work in the oil and gas industry. So we sat down and drafted letters, walked around, I think it was Yusuf Dule. We went to Talo Oil, gave them applications. We went to Sinop, we gave them applications. We went to Total, we gave them applications. We are moving around and we're not getting any feedback. They'll tell us, go and check on the website. If there are any activities, we shall call you. Why? Because then there was no activity. No one can hire you to work when there is no work. We just started drilling when? Around 2023. The final investment decision was signed 1st February 2022. So before that, there was not much work in oil and gas. It was more of research. That is what PEPD was doing research, formulating designs. But the real hands-on work was not there. So the opportunities were not as there as you have them now. But what sets you apart? You need to be resilient. You keep trying. I made several applications. I went to CNOC. It was, I don't know, 2014. I put in my application to do internship with them. They did not get back to me. I tried Total. I tried Talo Oil. So what did I do? I started working the fuel marking program. It wasn't where my ultimate destination, but it was the starting point. I was now in petroleum. But also you have to keep improving yourself. You see, when I was working the fuel marking program, I was working downstream, monitoring petroleum being sold at petrol stations. But I wanted to work upstream. That's where my true passion was. I wanted to be where there's drilling, where there's engineering, there's safety and all. So I had to resign from my job. I had to resign. I looked around. I kept trying. I applied for scholarships. It took me 2 years to get a scholarship. It wasn't instant. You try, rejections come, you develop a thick skin, keep trying, don't give up. I applied, I don't know how many scholarships. With Michael, we did write applications. We'd sit down and write, we share cover letters. I even reached out to some of the successful applicants to share with me, and I was not successful, but I kept trying. A whole year, nothing came. Then the second year, I tried Government of India, I tried the UK Commonwealth, I tried the Chevening Equity and Merit Scholarship. I could name all those scholarships, name by name. I try here and there, different courses, not only now. I'll try petroleum engineering, chemical engineering, environmental engineering. I was so open, but I knew what I wanted ultimately. I focused more in oil and gas. Sometimes I would get admissions. There's a time like in the first year I got admissions to 5 universities, but I had no scholarship. So keep trying. When they do not select you, try again, keep pushing. I think you guys have it easier. Some companies come to your campus and select graduate trainees. We did not have that. they come and pick maybe top students and they go and interview them and they advertise. Every year companies advertise graduate training opportunities. Currently, there's a graduate training opportunity running for Total. I don't know if you've seen it. Don't limit yourself. It doesn't matter whether, just apply. If you see anything that you think you can do, just drop in your application. It doesn't matter whether you have the required experience or not. I know quite a number of people who have gotten jobs for which they have no experience. So if you see anything, just apply. Graduate opportunities are running. Did you put in application? Is it because they didn't focus on chemical engineers? Once you see, just try. Then what I can tell you in oil and gas, these companies just want engineers as long as you have an engineering background. Doesn't matter. Chemical engineering, mechanical engineering, petroleum. Then they take you for training. For example, Total, they have a training school. They're not going to trust you with a project that's worth billions of dollars with your random skills. So they'll take you and then they'll train you. They just need you to know the basic engineering. So make sure, like Michael said, make sure what you know, you really know it. Learn your principles very well. Then be open, check out any opportunities that come up. Drop in an application. They'll hire you and they'll take you and train you. And you're not going to go that now work alone. You're going to have a team of people that you work under. When you join as a graduate trainee, probably you'll work under an engineer. Matthew can tell you he has graduate trainees working under him. He trains them. And this was super above him. You work in a system. You don't do work alone. So as you work as a team, you keep learning on the job. Like, you don't need to know everything. It's not like an exam, like you go and they say, now do the work. When you're doing exams, you can't access your books. You can't reference, use your head. The real world is not like that. When you're working, you can reference, you work as a team, you can do research. It is not like work using the knowledge you have on your head. So just be open, you work as a team, you will learn. So what I can tell you, keep pushing. When they don't shortlist you, try again, keep pushing. Eventually you will break through. And keep improving yourself. There are some free courses that you can do. For example, those who are interested in the oil and gas industry, before you work in the oil and gas industry, there's a certification called International Well Control Forum, IWCF. The first level is free, so that means all you students can do it. These are certifications that are recognized in the oil and gas industry. So when you do it, you put it on your CV. When you apply for a job, there's another student who does not have it, and for you, you have it. If you're an employer, who would you consider? This person has taken an initiative. Well, you may not be able to afford some of them, but some are free. Do some of those free online courses. Don't just let time slip by. Improve yourselves and look around. It will give you a boost. I think that is it for the questions I received. Unless there are any more questions, I hand over to you, Ethan, to moderate the next session.